Okay, hello everyone. Let's continue to our chapter 3, which are scripts and function files. This is one of the very important chapter. Okay. So, what are Matlab scripts? So basically, a script file, usually we call an M file, is a text file that contains one or many Matlab commands, and also it can also contain some commands. These commands are actually have no practical function besides letting you know some kind of notes for yourself or for others to follow your code. Okay, so script files always end with extension .m. When you want to call the script in the command window, please use the file without the extension .m. Okay, and there's no input or output arguments in the scripts, and any variables that you create during script file will actually stay in the workspace even after you finish the script. Okay, so basically a script is just a predetermined list of many commands that you want to enter into the command window. Okay, so because of that, running a script can change the data that you already have in your current workspace if you are not so sure. Okay, so be very specific, because sometimes some of the data are very important, and if we accidentally run the script and it will change, okay, if we use the same name. So it is advisable to keep very carefully about the variable names. So one example is to generate a kind of flower plot using polar plots. Okay, please try to enter this series of commands into a text file. Okay, so to make it convenient, I have already saved the list of commands into a file with the name petals.m. Okay, and what happens, so in the command window, when we type petals without .m, okay, so this is the result of the operation. We generate some kind of flower shape polar plots. Okay, as you can probably see, there are a list of commands in these files. Next, function files. So function files is quite similar to a script file in the sense that they also ends with the extension .m. Okay, and function file can be called from the command line like typical script file. Okay, so basically a function file is also contain can contain one or more commands to run a specific job. And when the function is called, the file is accessed and the control is returned to the Matlab workspace. Since the function is not generally a part of Matlab workspace, the variables and values are not known after the control is returned. Okay, and any value to be returned must be specified in the function syntax. Okay, so if we want to generate something for later use, you have to be very specific and have to specify them in the Matlab function. So basically a Matlab function is like a mathematical function where a rule is given to accept a certain inputs, then we to get some certain outputs. The inputs sometimes we call the arguments of the functions. A function always starts with a function definition line. Later on I will show you what is a function definition line, and always end with an end statement. Okay, so So whenever Matlab sees the end statement, it will know that that is the end of the function. So what are the difference between a script and a function file? A function accepts input and return the output. Okay. A script just basically just perform a series of commands that have been written beforehand. Okay, basically a function can have three kinds of forms. The first one, for example, var equals to function name, argument number 1, argument number 2, and so on. Or variable 1, variable 2 equals to function name, argument 1, argument 2, and so on. Or just plainly function name, argument 1, argument 2. So the function has its own memory locations for all the variables, and only the values, not the addresses, are passed between the Matlab workspace and the function. So in the three forms, so for example, the first one, only var is passed to the workspace. In the second one, only var1, var2 are passed to the workspace. And the last one, the result will be saved in ANS. Example, let's take a look at the example swap function. Okay, so basically this function will swap the two values. So the function will be function a, b. The output will be a and b. So the function name will be swap a and b. So basically it will swap position of a to b and b to a. In order to do that, the function needs a temporary variable. So temp, T-E-M-P equals to a. Okay, we assign the value of a to variable temp. Then we assign value of variable b to a. So a equals to b. Now a actually is having the value of b. Okay, and we assign the value of temp to b. Okay, so now b actually having the value of a, original a. Okay. Similarly, you can try to have the second function. Okay, the second function swap, receive two values and swap them using two additional new variables. Please try to input the first function by yourself. This is the example. For example, if x equals to 5, y equals to 6. So x, y equals to swap x, y. The result will be x, new value will be 6 and y will be 5. This is a typical structure of a Matlab function files. So in the beginning you have function output variable 1, output variable 2 equals to function name, input variable 1, input variable 2. And you can have a series of commands, okay, which start with the percent sign. So usually you guys can put a lot of memos about the functions, the intended use, and so on. And we have the body of the function, okay. In the body of the function, you must define all the necessary variables, or else Matlab will give you an error indication. So why should we use functions instead of scripts? Basically, functions can make your program become modular, okay? So you don't have to write a very long programs. Instead, you can break it into many smaller ones. Each one have a separate functions. So it is much easier to write smaller programs than it is to write a very long programs, okay? And your functions can call other functions. So this means you don't have to rewrite the code for the function again and again, and you just store it in somewhere so that later on you can just call the function out. And the most important things are variables in the functions are local. Okay, this means that if you have some variables in the current workspace having the same name, they will not be infected by your functions. Next, we're going to learn about the definition of a computer programs. So basically, a computer program is actually a sequence of instructions that we, the programmers, tell the computer what to do. These are the programming steps. At first, you need problem definition. Okay, so what is actually your problem and what do we want to do? And second, you need to analyze the problems. So you have to write out all of the appropriate equations, determine what kind of inputs and what kind of outputs do you want. Third step is to develop the necessary algorithm, okay, or processing steps to solve your problems. The fourth step is to actually write the code, okay. The fifth step is to test and debug your code, because honestly you cannot write anything that runs perfectly from the first time. So usually you have to test and debug your code. In order to do that, you have to write some test case scenarios, of course. The last one is to run your code for different cases. Example, let's say we want to write a function that converts the temperature in Fahrenheit to Celsius, okay? So, second step, problem analysis. So we want to convert a temperature in Fahrenheit. The input will be a temperature in Fahrenheit, then the output will be the temperature in Celsius, okay? So the governing equation will be the conversion from Celsius equals to Fahrenheit temperature minus 32 times 5 divided by 9. Okay. This one is common sense, you guys can learn from any basic engineering class. So next step is to develop algorithm or the processing step to solve your problems. Okay, so it will consist of 3 steps. First, the user need to input a single number that represent the temperature in Fahrenheit. Okay, then we need to assign those temperatures to the variable F8 FAHR like the previously shown in the equation. Then next step is to calculate the new variable Celsius using Celsius equal to FAHR minus 32 times 5 divided by 9. Okay. Then the last step will be to output the Celsius value to the user. Okay. So next step is to actually write the code. Okay. To write the code, we will write a function. Okay. So our function name will be F to C, so basically from Fahrenheit to Celsius. So the function will be something like this. Function Celsius equals to F to C. It will receive the input, which is FAHR. Okay. So the commands, this function converts Fahrenheit temperature to Celsius. And the working equation will be Celsius equal to FAHR minus 32 times 5 divided by 9. Okay. So in order to do that, in Matlab, please click to generate a new script. Okay. And type in everything, the function. Then we save this one as f2c.m. Okay. You don't actually need to type. Okay. So please pause the video and try to make the function by yourself. Next, the step of testing and debugging the code. If your program works perfectly fine in the first time, then it has no bugs, so that it is very lucky for you guys. But usually you guys will have to do some kind of debugging so that there will be no errors. And next step is to run your code to determine whether the output of the functions actually satisfy the condition that you guys want it to be. For example, we all know that Fahrenheit to convert 212 degrees Fahrenheit, it should be 100 degrees Celsius. So if your program did not provide the correct answer, then you guys need to go back and check one by one. Okay. So another example, please do it by yourself. In this example, I show you guys a function that computes the time for a falling object to hit the ground. Okay, this one is very typical physics problems. So please follow the equation and try to do it by yourself. Okay. So 6 steps. First, problem definition. Next, problem analysis. What kind of input, what kind of output do you expect? Then develop algorithm. So the steps. Okay. What kind of inputs, what kind of equations? Then write the code. The code actually is shows on the slide, so you guys just need to retype. And test and debugging, these are the results that you guys will have to get if your program is supposed to be running fine. Okay. So practice. These are the things that you guys have to do. So please write a script to calculate the hypotenuse of a square triangle. You guys will all know that the hypotenuse of a square triangle will be a square root of 2 times the other side. Okay. So hypotenuse is actually căn huynh. The second problems, please write a function to calculate the hypotenuse of a square triangle. The first one is a script, the second one is a function. Okay. The third one, please write a function to calculate the sum, product, and average of 5 numbers. Okay, this one should be easy enough. Next one. So let x equal to minus 5 times minus 8j and y equals to 10 minus 5j. So these are imaginary numbers. So use Matlab to compute the magnitude and the angle of x times y and magnitude of an angle of x divided by y. Okay. And use Matlab to find the angles corresponding to the following coordinate. X, y equals to 5 and 8. So the angle to the origin of the axis, which is 0, 0. Okay. That's it for this chapter. Okay. Thank you very much.